this problem is one of our famous linear programming problems. Lisa has an online jewelry shop where she sells earrings and necklaces. It takes her 30 minutes to make a pair of earrings, and it takes her 1 hour to make a necklace. Since Lisa's a math tutor, she only has 10 hours a week to make jewelry. In addition, she has a restriction on her materials. She only has enough materials to make 15 total jewelry items per week. Then there's some information in here about profit, right? She makes a profit of $15 on earrings and $20 on necklaces. So how many pairs of earrings and necklaces should Lisa make in order to maximize her profit, assuming that she sells all the jewelry that she makes? So let's take this and move it onto our linear programming template. So first stage is to define the variables. So here the question is about selling her jewelry, how many earrings and necklaces. So we will let x equal number of earrings that she makes, number of pairs of earrings, and we'll let y equal the number of necklaces, So in black, we have each earring takes 30 minutes, which is a half of an hour to make, and each necklace takes 1 hour, and that she only has at most 10 hours to work through the week. Then she has a restriction on the number of materials that she has. So she has only enough to make 15 total items. So the number of earrings she makes and the number of other items have to add up to become at most 15. In addition to that, we have these trivial constraints that are often floating around that we can't ever be negative. So there is our setup of our constraints, and then what we're trying to maximize here is the profit. Whoops, I actually meant to do these in different colors, so let's align it with what's going up there. I meant to make this one red. X plus y is less than or equal to 15. And then the other ones are the trivial ones. Okay? So the blue will be used to represent the objective function. So the objective function says that would be the profit, because we want to maximize profit. So she makes, for her profit, $15 on earrings and $20 on the necklaces. So I believe that's good, translating all of the information over to our template. So now we're going to use that top quadrant with the equations and the constraints in order to be able to do the second step, which is to draw in the feasible region. So for the black equation, if I were to let x equals 0, y would be 10, and if I were to let y equals 0, x would have to be 20. So I get 0, 10, and 20, 0. So coming over to the grid, this is a 20 by 20 grid, so there's 20 spots. So I need to go up to 0, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 20, 0, which would be located out there. Whoopsies. So now, connecting those, there is our first line. Okay, now in red, we have our second line. The second line is x plus y equals 15, so that's going to go through 0, 15. That was 10, so 11, 12, 13, 14, 15. And then that was 20, so there's 19, 18, 17, 16, 15. So connecting those two will give me this line. Okay? Both of these are less than or equal to, so it's going to be below the red and below the black, and it's going to have to stay in the first quadrant. So the region of feasibility is going to be this region right here, which has 4 corners, which I'll call A, B, C, and D. Okay, the coordinates of A should be pretty clear, right? A is 0, 0. B was the black line's y-intercept, and the black line's y-intercept is located at 0, 10. C is the red line's intercept, x-intercept, so that would be 15, 0. And then D is the only one that really takes any work because that's where red line intersects black line. So remember, the red line is x plus y equals 15, and this line right here, the black line, is half of an x plus a y equals a 10. So to figure out where these intersect, let's do some elimination here. X minus a half an x is a half x. Y minus y is 0, and 15 minus 10 is 5. So therefore, x would be equal to 10. And since x plus y must be 15, that means if x were 10, y must be 5. So then let's take those points and plug them into our objective function. The profit equation at A would be 15 times 0 plus 20 times 0, which is 0. And this should be pretty clearly a minimum profit, right? That's not going to be a maximum profit. Lisa would not like that deal. The profit at point B would be if she only made necklaces. That would be 15 times 0 plus 20 times 10. And from that situation, she would make 200. How about at point C? There she gets to make 15 of the earrings, and she gets to make none of the necklaces. 15 times 15 is 225. So she makes a little bit more money from that situation. And finally, point D would be 15 with the 10 and 20 with the 5. And this is, of course, 150, and this one's an extra 50, right? $150, sorry, not 50, that'd be $100, and 100 plus 150 is 250. So there's our happiest profit. So what would the conclusion to the problem be? Lisa should make 10 earrings and 5 necklaces for a max profit of $250.